What you see before you is what we call the WYSIWYG editor. That stands for what you see is what you get. So generally, this is going to be a very similar UI to what your students will experience when they load up a lab. So when you first load up a lab, you're going to get kind of overwhelmed with the amount of language options that you have. So you'll just have to scroll through and select the specific stack that you want to use. We are going to use Python for this demo. You can check the technologies that are installed on each stack by clicking on it. So this will load up the different types of libraries and installed software for each stack. So if I go ahead and I click on the Node.js stack, you will see the technologies are different. So you can see we have, just going to refresh real quick. You can see that we have different testing libraries, and then there's the default software as well. We're not going to go over everything because there are just kind of a lot you can do on our platform. So we're just going to kind of cover the basics. So we're going to include selecting a stack, which we just did, setting up the instructions, setting up files, and creating some tests. So there are actually two ways to add instructions onto our platform. The first is directly. So you can add a markdown file directly from the instructions. We use GitHub flavored markdown. So I'm just going to create some instructions real quick. So you can kind of see some basic markdown highlighting in the instructions. There is another way to add instructions that's pretty popular, and that is through Git. So we do have the ability to allow our creators to host instructions on GitHub, and then you can sync those instructions from GitHub to the platform. And the way you do that is you head into the settings, and you want to scroll down to GitHub sync settings. And here is where you will enter the name of your repository and the username. So in our case, it's going to be next.xyz/webinars. And then if I go to the instructions, you should be able to add a GitHub markdown file. So it should be webinar 002 instructions. Let's see if I made that correctly. So as you can see, these are the instructions that I have hosted on GitHub. Nothing too special, just to show you guys the demo. One of the reasons why we love GitHub is because the version control is obviously huge. So you can you can either host different versions of your instructions, or you can track the changes that were made. The one thing we currently do not support right now is the ability to edit GitHub instructions on our platform. So you can only edit the link. So all the editing still needs to be done on GitHub. You can also sync in files. So if you are also hosting starter and solution files, you can go back to the same setting and you can create file links. So this would be the same format as the instructions. So we're going to do webinar 002/starter. And if I did that right, you should also see the starter file appear. So this is a really great way for teams to manage their content and edit their content iteratively over time. So if you have any questions about that, I know another popular feature request we have is the ability to upload to GitHub. That is something that we currently have in our development pipeline and we are actively working on. Students still have the ability to use GitHub through the terminal, but as for a built-in feature, that's something that we are currently working on. I'm going to go ahead and type out some code. All right, so here we have a really basic Python program, and it's just going to add two numbers together. So one of the things that we've done in the creator to make it really easy on creators is we've given you guys the ability to run code straight from this environment. So this is called the edit environment. We also what we call the preview environment. The difference being is one doesn't have the settings. So here in the instructions, you can see I have all these tools and these features to edit. If I didn't want to see that, if I wanted to kind of get rid of that ability and kind of view it in kind of how a student would, we call that the preview mode, and you can do that by clicking the preview button up here. So this is what a student would see if they were to load your lab. So if I go ahead and run it, barring any embarrassing errors, I should be able to run my program. So as you can see with the program I just ran, I'm not getting the result that I would expect. I'm kind of expecting to add two numbers, but 2 plus 2 does not equal 22. So there's something clearly wrong with my logic. So let's see if we can write some tests to sort that out. So we offer a pretty large variety of tests, what we call checks in the platform. The ones that we're going to be working with today are code patterns, test cases, and unit tests. Those cover, and I'm making a percentage up right now, but probably about 75% of all test cases that are used on our platform. So I'm going to go ahead and I'm going to create a test case first. So I'm going to add a description. So let's see. And the descriptions do support Markdown, so we like to kind of keep everything consistent and themed throughout. So we added support for Markdown in our description. So let's do addition adds two numbers. Let's make the input 2 and 2. And the expected output is going to be 4. The way we work with our checks may be a little bit different than some of you have seen, if you've seen anything else, but we tend to group them into what we call tasks. And the reason why we do this is because you may have, as you'll see shortly, you may have multiple different checks that are designed to test one specific functionality. So in this case, this program, we're only doing one thing, and that is creating kind of like an addition kind of function. But if we were creating a calculator application, we might have addition, subtraction, multiplication, and we need a way to group those together so that a student is able to kind of go in and they may only be able to implement, addition and subtraction. So we want to be able to give creators the ability to afford the students the ability to go in and create maybe just half of the functions that they're able to, but still get credit and still get that right and still submit that to their instructor. So I'm going to come in here and create a task real quick. You will see in a little bit where it says link checks will be listed all the different checks that we have available or that you've created for that student. And all you do is simply go in and link them to that task. And tasks are what students will see if you decide to embed those tasks into the instructions. And they are also what shows up in the task list. This is also where you'll provide feedback for your students if you want students to have a little bit more feedback. So in this case, they're only adding two numbers together. So if they get an incorrect answer, some of the feedback might you might want the feedback to say something like, make sure you double check your logic. And if they get it on their first try or any try after that, great work. We're going to disable the same directory because we do want our tasks or our checks to run in different directories. For this particular assignment, there are use cases where you want them to run in the same directory, and there are some pretty clever tricks that you can use with the same directory to get some pretty cool results, like testing the output in a file. If the shared checks button is on, this means that the checks that comprise a task will be visible to each student. So there are circumstances where you may have multiple checks to test this addition method, but you don't want the student to know what they are. You can disable the student's visibility. So when they run their tasks against their method, they may only get a positive or negative feedback, kind of like a pass-fail. And the check is live, so we do have the ability to add it into the instructions. So let's go ahead and create that. And let's make sure that the student isn't cheating. Yeah, let's go ahead and add one more test real quick to make sure the student isn't cheating. So we're going to add a code pattern, and this pattern is going to be pretty simple. This will test to make sure that a student hasn't looked at our test case, hasn't seen that we're looking for the number 4, and decides to, or thinks they're clever and decides to just kind of print it out directly. We're going to add that to the same task. And let's see how I did. Yep. Doesn't look like it found it because 22 is not 4. Let's see. Just want to see what this one is. I actually did mess that one up. So that one should have passed. So let's just run that one more time. So here the code pattern is looking to see if I hard-coded the 4 out, and I didn't. So that should pass. The reason why this isn't passing is because the inputs are currently strings, so we want to convert those to integers before we return them. Now if I run this program, I should be able to get the correct answer. 4. Let's run our task one more time. As you can see, now I got the right answer, but there are still some cases where you may want to add additional tests. So one of the things that we were working through is a unit test. The logic here was flawed before we corrected it, but a unit test would still pass. So if I were to run a unit test on addition, the student would see that their addition program still gets back the correct answer. So one of the reasons why we encourage the use of tasks and multiple different types of tests is for this exact reason. If an instructor had only used a unit test and had tested the addition method, and if you guys would like, I can walk through the creation of a Python unit test really quickly. Just send Andrew a message in the chat and I will do that. But one of the reasons why we encourage the use of multiple different testing interfaces is because of edge cases. So the logic in the addition method, given the correct inputs, is correct. So there are instances where a unit test would pass, but the test case would not. So using those three different types of tests, it helps narrow down where the student isn't kind of putting two and two together. No pun intended. For that was really bad, but I promise it wasn't planned. So in this case, the string input was getting added together, so it was kind of concatenating. So it was a string character of 2 and another string character of 2 getting added together to create a string character of 22. While a unit test would pass, given the inputs of 2 and 2, a test case failed. So that's why we encourage that type of format. Are there any other questions thus far about what we've covered? Is there anything specific that anyone wants to see? If not, Andrew is going to go over a couple of the more advanced features, such as startup and build scripts. But if you do have a question, just shoot us that in the chat.
All right. So we also support some scripts that you can run. So I'll go back into the edit mode. So if you go down into settings, there's some. So you can add a startup script. So this will run whenever the student's lab loads. So it's useful for installing any libraries and software that the lab uses. So if you want to type something like so something like that, we'll install the NumPy library for Python. And we also have build scripts. So build scripts are mostly useful for compiled languages such as C++. So that will just run the G++ compilation command or a make command if you use make. And we also have some various other fields in here, such as a pre-save script. This one isn't used too much, so you can usually just leave this one blank. And we also allow a program entry point. Sometimes the editor is set up to run the open file, but if you want to run a specific file, you can type that file name in here. So something like, so that will always run the addition.py file. And as you can see, we have the GitHub sync settings that we looked at earlier down here. So you can also create tabs in the lab. So when you're in the editor, you can see all the tab types. So if I want another terminal, I can create a terminal. And if you do add a tab, click the save button. Everything on the left side of the screen is auto-saved, but everything on the right side of the screen needs to be saved with the save button. And we also have some interface layout settings that you can toggle. So this is a 2-pane vertical layout right now. You can change that to horizontal, or you could do a 3-pane. And you could create a new tab in this 3rd pane.
So here Andrew's loading up a GUI viewer. So if we were writing a GUI application, we would have the ability to both use the terminal code editor and the GUI all at the same time.
All right, and as I said, just click save to save that new tab that was added, and you're good to go. So if we go back here, one other thing I will mention is that the startup script run every time a new project is open. So in this creator right now, this hasn't been installed. So if you add something here and you want to use it immediately, just go ahead and refresh the web page. Obviously, make sure you've saved any files or tabs that you've added, and then refresh it, and this startup script will run, and you can use that in your lab.
Does anyone have any questions? Okay, awesome. If there's nothing specific that anyone else would like to see, that will conclude our second webinar. If there is something specific or anyone has any other questions about the platform, just shoot us a chat real quick or send us a follow-up email. Other than that, we hope you enjoyed this really, really brief rundown of our platform and kind of getting started with a quick Python lab. Let us know if you have any questions and have a great day.